So, good morning, everybody from Berlin. This is the ERCI webinar on digital twins for the exchange of railway infrastructure data. And my name is Lutz Hübner from Berlin Partner for Business and Technology, representing one of the members of the European Railway Clusters Initiative, that is the cluster Transport, Mobility and Logistics in the German capital region, Berlin and Brandenburg. And before we start with our webinar, I give you a short introduction on ERCI. ERCI is the European Railway Clusters Initiative, founded in 2010 and being a legal entity in Brussels since 2022. For the moment, we are covering 17 railway clusters, which are covering 16 European countries. That means for some countries, there are more than one cluster represented in ERCI, for instance, from the UK and from Turkey. And ERCI represents over 3,600 organizations, of which are about 2,300 SMEs. Managed by the regionally focused clusters, and for sure we have also good contacts to universities, R&D organizations, education institutions, incubators, accelerators, and so on. What about our services? Our main services is for our main target group for small medium-sized enterprises of the rail sector, and we want to improve the visibility on European level and partner matchmaking in R&D projects. That means if there are upcoming calls, for instance, on Horizon Europe, we are keen to support you in building consortia for successfully applying to the grant or the funding the European Commission is spending or is willing to spend for R&D activities. Yeah, support, also general support for small and medium-sized enterprises, not only R&D, also finding new market opportunities, getting visible during trade fairs, for instance, like the InnoTrans and other important fairs. Then we have our yearly event, the 10th time this year is the annual ERCI Innovation Awards. In some regions, the pre-selection is already closed. In Berlin-Brandenburg, it is still open until the 22nd of May. And after these regional pre-selections, every cluster organization has the possibility to delegate at least 3 applications to the European contest. So we are also in discussing innovative topics like cybersecurity, multimodal logistics, green and sustainable mobility. Upcoming topics are, for instance, human factors and the management of data for future rail application cases, and therefore we are installing task forces in order to get in contact with organizations from other regions with the same topic, also to discuss how to build a consortium for a future R&D project, and so on. And we are also doing bilateral workshops, physical ones, and also digital ones like this ERCI webinar. Our contact data it would be the first to put into the chat by my colleague ERCI from ARUS. We are for sure present at the World Wide Web, at X, at LinkedIn, and for sure we have also an email address. You will find all this information afterwards, after the presentation, after the webinar. I will send out a follow-up email, including all the presentations of today and also the link to the recording. So, coming to the first presentation, which is held by Jonathan Eyre from the University of Sheffield, from the Advanced Manufacturing Research Center. And the title is Establishing ARUS Sectoral Digital Twins Across Data Sharing Infrastructure. Let me introduce Jonathan a bit. He is a Senior Technical Fellow for Digital Twins at the AMRC. He leads a range of client work and grant-funded programs focusing on digital twins and their key enabling components, such as information management, cyber-physical systems, data connectivity to enable digital transformations. He is responsible for a portfolio of research across a range of industrial areas, primarily within manufacturing, to solve industrial challenges to drive business value. Jonathan, the floor is yours.
Thank you very much, and good morning, everyone. It's a pleasure to be here this morning, and I really want to cover in the sort of next 20 minutes everything that I'm aware of going off in the UK space and really how we're going to get this right together across this particular sectoral area within rail and adjoining sectors. So whilst being primarily from the manufacturing sector, I want to apply that and look at some of the research we've done in transport to understand how manufacturing plays and establishes these sorts of cross-sectoral digital twins. Now, digital twins, I appreciate, might not be a term that everybody knows, so I want to go through some of that. I'm going to talk through some of the what does it mean to be cross-sectoral. I want to embed that with some use cases and actual demonstration we've done of proof of value for some of the clients we've been working with. Now, the clue around digital twins is that digital is there. So obviously there is within that, there are a lot around about information. And the first question you have to ask is, why do we need information? There's no point in doing any of this stuff around digital transformation if there isn't driving business value. So really, the point of information is to make decisions. And that's really a key of what decisions are you trying to make and what information do you need to back that up. And what those decisions then enable you to do is to move towards business, to drive the decision making to affect the business. So across all of these layers you've got, with information, it can help you identify the business opportunities. With decision making, you can then decrease the risk, and ultimately you're then reducing costs, responding to change better as a business. The target obviously being competitive advantage. What can you do better, smarter, faster, cheaper, all of these things to move towards it? Now, the trick is you can't just get any piece of information and that's good enough. You need something called quality. Now, data quality has been around for quite a while, and it seems to be the elephant in the room around everyone wants AI or everyone wants to do better things with data science. But it's the quality that's really holding it back with regards to, there's common statistics around 60 to 70% of data science is just prepping and understanding to provide context before you do your analysis. So quality is really important for this. Now, there is properties of quality. Now, this has been out for over 10 years. It was a book by Matthew West, and it ultimately led into an ISO standard called ISO 8000. And people just think of it as some of these. So they think about consistency or clarity or accuracy, but they don't consider the holistic picture. So I'm not going to drill into each of these, but it's just to say, think about the quality of your information to start to drive decision making. Now, often when you get data and you've understood its quality, you start to look at the digital transformation of going, okay, what can we now do with this information to drive the understanding and business? And typically, you start to look towards dashboards. So many organizations are rolling out Power BI dashboards or their own implementations just to go, I've now got some data, what can I do with it? So on the left, a fairly traditional dashboard, and on the right, more of a sort of an AR experience. And these start to give the subject matter experts, the engineers, the people who need the data, the ability to interface that when you're deploying these sorts of IoT systems or connectivity platforms to understand what on earth is going on as we start to get to these more complex cyber physical systems. Now, they start to head towards digital twins, and I'll start coming into that sort of space now. So the image that was shown as sort of the introduction to this webinar is typically what you find when you Google digital twin, especially if you put train or railway next to it. And I honestly think sometimes these help, sometimes they really do not help with regards to understanding the concept and the approach we are talking around with digital twins. They are more sort of colloquially understood to be sort of the synchronization between whatever's happening in the physical world. We want to understand that within data, information, and ultimately knowledge so you can make informed decision making. Now, that might sound futuristic, but actually a lot of the time we're already using these as consumers. We already have weather applications, traffic management systems, car dashboards. Back to the dashboard piece, it's this first layer of going, what is happening with this system? How can I use that information to drive decision making? And ultimately, how can I predict what is going to happen to make better decisions? And that needs the quality, that needs the trust, the provenance, the understanding of what that data means so we can make the best decision possible. How often are people now looking at Google Maps or equivalents to go, I'm going to use this before I set off on my journey to understand delays? There is a trust there in the data source to then understand what can I now do as I move forward or start to do this sort of thing. So my challenge is, where is that for organizations? Where is the Google interface or other services are available to go, what are we doing to enable our engineers, our staff members, our colleagues across different organizations, their interface into understanding what is happening to help them do their job? Now, some of the language I've used is also available in another ISO standard, 23247. So people go, oh, well, lots of organizations are defining their digital transformation strategy. They're defining what it means for them to have a digital twin, which is great. It needs to happen. But a lot of that language is already determined across international communities within this particular ISO standard. So it's about synchronizing, as I mentioned, the physical to this virtual representation to understand what is going off. And it needs to be fit for a purpose. So we aren't here to say, collect every single piece of data and try and understand it all. That isn't going to work. It doesn't scale. You end up with massive data lakes and none of it's useful, costs you a fortune. But it is about going, for this particular use case, there's some of the examples I'll show in a second, look, trying to understand what is the purpose for using that particular piece of data for that particular use case. And we can see some on screen. So what's the sort of production scheduling assurance? What's the sort of understanding dynamic risks? What things are you trying to twin to enable health checks or predictive maintenance? It's those sorts of things that you're probably already doing, or at least doing some of them, and you might not have even realized this whole framework around it could actually enable it better for you. Now, there's different scales of twins, and that's something else to get across with regards to if you are large organizations, large asset owners, infrastructure is massive, and you're talking sort of millions of pounds worth of savings if you wanted to try and understand better sort of data-driven decision making about these sorts of things. So one of the UK's big initiatives at the moment is the National Underground Asset Register. So they were seeing sort of heavy costs with regards to digging underground and not realizing what was there or the information was out of date. So it's a case of actually reducing utility strikes based on actually understand what's there, or actually I can now federate and share the data across different organizations. So we're all working with a single source of truth. Now, some of that terminology may be already familiar with you, but it's about understanding how to go about doing that to get the efficiencies of, can we all start working together better rather than dealing with and paying people to manage their own spreadsheets and then struggling to understand how they're utilizing that sort of mechanism. So that gets down to the decision making, but there's a nuance here that I just want to sort of discuss with you is around, we still send these around, probably in paper in some respects, but at least they are moving towards more digital copies and sign off. But a case of that's a document driven decision making, and you're trusting the engineers to go, what part of that document do I need to go to make a decision? Well, as part of digital twins, we are seeing it as much more of a broader digital transformation. So the paradigm shift is then changing from document centric to data centric. So understanding what bits of data, what bits of information do I specifically need to go, I want to make a decision based on these particular areas. Because what that means is when you then want to send that decision making capability to somebody else, you're only sending the part of the information needed to them. It means you can put the appropriate security around it. It means you can put the appropriate understanding and mechanism for it. So you're not sending them everything and overwhelming them, which then accounts for the better reference architecture as we start to look towards these IT systems. So one of the things that is helping that concept, it's mainly from a manufacturing perspective, but we are seeing it coming across within transport now, is a concept called a unified namespace. Now, this is still conceptual in some regards, but it's building on technology that's been around for quite a while. And our approach, which you can find by just quickly Googling AMRC Factory Plus, is around our specification of our recommendation for how to go about creating a unified namespace. So one of the things that often IT professionals talk around, and we start to get towards the value, is a reference architecture. And at the moment, there's lots of things, so application programming interfaces or APIs are available that allows systems to talk to each other. Sometimes you have to take a CSV or an Excel cut and then import it into the system, but more often now you are seeing this sort of big sort of connectivity of different systems. Now, this isn't to jump into what specific boxes are on that page, but this is often called spaghetti or a ball of mud of things all talking to each other. And it's the principle of, if I wanted to replace my historian, I've got to replace all of the connections that are made into the historian. So we're looking at smarter ways of decoupling, sort of reducing vendor lock-in about these systems. So Factory Plus, as I've mentioned, is available and open source specification. And it's a blueprint really for how to start to connect your facilities, your sort of supply chains, and looking at that sort of thing of how you want to share data. And it's looking at from extraction to transport to storage to processing, and looking at that lower level of digital twins to actually understand what data you're using with different things. And when you start to implement it, you get much more of this sort of approach where things are open and accessible with the right security mechanisms. So if you wanted to replace your historian, you replace your historian without changing any of the other pieces of the reference architecture. So it's much more of that publisher subscriber model rather than constantly requesting the latest update off the system. And that mechanism is really changing and having sort of real advantages for manufacturing and transport, to be honest, with regards to some of the trials we've been doing. Now, jumping into some of the specifics, we've been looking at demonstrating smart technologies with some respects. So I've mentioned broadly around data and how we're getting there, but often when the part that we do within translational research is around demonstrating that capability. So how can we manage rail assets? How can we look at maintenance? Part of this was looking at S1000D, which is a specification for understanding the language used within work instructions, and really trying to help people understand when they are going through digital transformations, looking at what steps they should be taking to deliver them value, to understand how they should be moving forward. So the real thing here is you can look at bits and pieces, but it's really a case of how does all of that stitch together. So right in the center, dashboarding was still key for this project. We still wanted the subject matter experts or the key engineers within that organization to go, what can I now see of the system without dealing with Excel and the paperwork I was used to dealing with? And then we could start attacking some of the asset management, start looking at optical recognition through camera and vision systems, but driving that with the experiences of how are we structuring that data and how are we making it accessible to these different projects. The other thing I just wanted to touch on was a piece of research we did around shoe gears and looking at the vibration of the rails to understand actually how should we do that monitoring system. So this was a piece of work that looked at the geolocation across the vibration range to start to understand when rails were needed maintenance or whatever else. They knew when shoes were failing to understand there was a fault on at least this part of the track or roughly at what time it was recorded, but that was very manual. We actually then linked that in with the sensors to go, actually, this is where you need maintenance. So it was the reduction of guessing where maintenance was required. It was a reduction of when maintenance was required. It's a case of they can now more tactically go, this has been a problem. Now, this is still very much a reactive maintenance process. We know as it fails, there is now an issue on a certain part of the track, go fail it. We're trying to move towards more predictive, where it's subtle on the vibration. So it's not large spikes, it's this is starting to become an issue. And that's ongoing research within this sort of space. Again, this is small pieces of data. This is location and vibration. We aren't talking when we are twinning these sorts of assets, lots of data. You can, and some use cases need that. but often the starting point is much smaller of where can you have value to start with as you start to build up your ecosystem of twins. Now, I've spoken very sort of broadly and within some particular examples around single digital twins. What we're starting to look towards then, as I highlight on the title slide, cross-sectoral digital twins, or how do we share data across multiple organizations? So it's a case of looking at, we're all interfacing with the natural environment. And at the end of the day, we want to deliver value to citizens, to social infrastructure. And it's the transport, it's the energy grids, it's the other aspects that we want for the economic infrastructure that's layering it together. And there is no point having lots of different sort of silos of truth for these different areas of information we want to get out of it. We need to look at how we connect those and federate them together. Now, if that wasn't complicated enough, we also want to do that across the whole life cycle. So we all want to reuse assets. We want to recycle stuff. Well, we need bits of information across the whole life cycle. And this is another area that digital twins are looking at with regards to a particular area called digital passports. So they are slightly different, but the passport being what data do you need along the whole life cycle of a part so you can hand all that over. We are still used to handing over ring binders or massive pieces of paperwork to go, this is how you manage that system. Or here's a SharePoint access where we'll update the documentation for you. We're looking at much more of how all of that data stitches together. And one of the other ISO standards in this space is 15926. And that looks at how you describe parts of data all together to capture information about assets and processes. So what information are you capturing on a process to help with that area? Now, that's one way of looking at it, and the two particular different lenses I've just given you. But the other thing just to highlight is, and this is an example from the energy grid in the UK, current physical infrastructure is physically connected. It's the clue is in the name around how does power and energy connect through to charging infrastructure or rail, or what's that distributed mechanism? And that is fairly easy to secure. There is physical security you can put in place. There's an understanding. But we want to get the benefits of the digital twins and the federation of that data. So how are we looking at establishing that data sharing infrastructure to what is happening across that sort of reference architecture? So this is how sectors are starting to talk to each other. They want distributed and federated ecosystems with understanding the language, where ideally the humans are doing the innovation, not the, I want to send you this information, is that okay? And then spend 6 months getting through contracts before they can start sharing data. So there is a whole reference architecture behind this by National Grid ESO. There's a link there at the bottom of the slides are distributed. It's a case of looking at, we have the physical infrastructure. How can we start bridging into these cyber physical systems to get the advantages of the things I've been talking around? Now, just to highlight some of the other use cases for this is around depot modelling. So when we have bogies and rail infrastructure that need maintenance at different points in time, you start to see, well, it's not just one operator, it's the maintenance crews and the contractors, and understanding that data sharing as we come into these sorts of things. But it's also then the network, the understanding of what can be done is also then a lot more complicated of understanding what bogies can be done if suddenly a bogie means or a train loco means that's not available for the sort of the transport request it was supposed to be doing. So it's looking at what we're doing with this one was discrete event simulation. So starting with a simulation, but then linking it into the synchronized data. Ultimately is what we've been moving on to go, okay, what's the best use of resources now? Who's available? How long is it going to take? What can we do to go, let's look at the decision-making capability that people want to have to ultimately move forward. And some of the trials that we did with them was go, what used to take hours of planning can just be a few minutes. It goes, this is the understanding and the synchronization of what's happening right now across all of these different systems to run a simulation to go, right, this is what we are suggesting. And that's providing now the end engineers, the subject matter experts, the ability to still do what they like, but it's an aid, it's an augmentation of their intelligence to go, this is what we could be doing, and it uses that to help support them of going, oh yeah, this is natural, this is most of the value, this is most of the way we do it, but actually I'd move some of the resource over, or I'd move some understanding. It's the same principle as a sat-nav. How often do you ignore a navigation system in your car because you know better, or you've got a little piece of information that the intelligence hasn't been built on because of traffic at a certain point of day or whatever else? So it's looking at how we can work alongside the system so we're still doing the really interesting stuff and the bit we often come to work for. Another piece of work is around looking at the service side of it, so the end customer experience, really, around how we're integrating this sort of thing. So this was a piece of work we did around at St Pancras Station in London, and it was a case of going 4G and 5G was starting to be trialled on rail systems in the UK at the time. It was a case of looking at, well, how do we stream the data to the cloud, and how do we make sure that the access to the data is available for the particular engineers at the right point in time. So HoloLens and AR was still being trialled as well, and to some extent still is. It's a case of, well, how are we gathering the data? How are we making sure that it's accessible to the point of going, what's the hardware requirements, what's the software requirements, and how are we streaming that back down to the end user as well? So much more on the maintenance side, but reducing the cost, reducing CO2 emissions, reducing maintenance activities overall, because you're now utilizing the data rather than sort of lots of engineers running around to check all these things manually. So it's much more of that ecosystem. And the point here isn't to go, look at all the examples of digital twins. It's to highlight, here's how to start digitally transforming organizations and take advantage of twins. Now you've understood the concept as and when required. So to wrap up and really look at some of these sorts of things, it's a case of just some reflections, I think, to help with this community around stuff we've seen within the rail sector, but also then the connections that you have into other sectors. So digital quality is really, data quality is really critical to enable digital transformations, but in particular digital twins. If we're having a conversation, you build up trust quite quickly with other people. You don't build up that trust in the same way that you speak to a system and the system transmits that data for you and somebody else is receiving it. There is no personal connection there. And it's a case of that machine-to-machine communication enabled by different people pushing into the system means that the mechanisms and the quality has to be quantified before looking at that data sharing infrastructure. And that's sort of really key for getting right in your own organizations and then as you start to federate. The other big thing around this stuff is people think, oh, digital transformation, it's going to take years. Yes, it will, but it's an ongoing iterative process that you'll go through. But that isn't to say the use cases that you'll find will be years away with regards to return on investment. You'll see that within months. And it's a case of looking at what do you need to twin, what pieces of data do you need to drive your decision-making capability as a business. So it's a case of embracing digital twins as part of these transformation efforts that we're all making. Very much heading towards data-driven decision-making, not document-driven decision-making as we all have historically done. The other sort of caveat around on sort of the near term is around sometimes people just accept manipulating spreadsheets as your job. And it's a case of that means that actually we are investing in people rather than sometimes investing in the systems that could help everybody's lives and get better staff retention and also help to manage with tacit knowledge. So it's a case of looking at that and actually being fairly frank with organizations of going, this is what actually some of the issues are as we start to look at business practices. And then ultimately, some of the last few slides I've gone through can be around data sharing across sectors and even supply chains as we start to look towards digital thread, digital passport, looking at this federation. So that's where the longer term opportunities are for digital twins, but it's a case of looking at how we are looking to federate and distribute that once you've got your own internal organizations established with regards to this sort of approach. Thanks very much for listening, and I'm happy to take any questions.
Yeah, thank you very much, Jonathan, for this interesting presentation. It's worth to mention that you and the Advanced Manufacturing Research Center is a member of one of our ERCI clusters for the Rail Forum. It's based in the UK, for sure. And yeah, we prepared some questions to you, which can you see on the slide. And the first one is, what do you believe is the biggest issue still preventing organizations adopting this approach?
Yeah, it's a difficult one with regards to being able to help people advise where they can get started. I think there is still a big thing around every organization has subject matter experts. It's the skilled staff who have been within their organizations for sometimes up to 30 to 40 years. And it's a case of looking at, well, what do they want for these digital twins? How are they looking to get the benefit of what's their non-value added time? And that's where you can start to look at these sorts of approaches of going, what are they twinning, but also what are they doing within the wider context to enable transformations? If you start to work with, as we do at the AMRC, with regards to organisations and their transformations, you can map out what they currently do. And you might be able to fill a room with lots of paper around, well, this is the process from start to finish. And when you start to go through the transformation, you can look for non-value added activities, and it can actually be compressed by quite a lot. Is working smarter with data. We still find ourselves where we are utilizing IT to do what we did before, rather than accepting and working with a new paradigm shift with regards to how we could be working better with these types of systems. So it's a case of looking where the non-value added capability is within what people do as their role, and looking at how best to support the most people to get the quickest return on investment.
Yeah. Second one, what is the best way to get started with digital twins and data sharing infrastructure?
Yeah, so the best way is to try it and look at the best way of going, well, what are we trying to understand about the physical things? A lot of people within manufacturing are looking at shop floor connectivity. A lot of people within transport are looking at much more of the what assets are where, whether that's GPS locations or Wi-Fi when it's in warehousing or whatever else, to go try and get the trust and the mechanism of understanding where to get access to information. And then you can start to share that across the organisation to the correct roles as they need that information to understand actually and aid their roles in what they're doing.
Yeah. Third question, is the availability of data needed for railway applications a challenge?
Yes, it is definitely a challenge, and then that's where it's a case of working with what you've got. Some of this, as I mentioned, is more of how you embrace that as part of a digital transformation, but it's also then your lack of data in a particular highlights your lack of quality or your lack of context around a particular thing. So it's always a case of understanding that is actually a really good first step to go, we can't do this because we don't have access to this data. Then that can actually drive the business case of, well, okay, let's start making sure we have access to that data now. And that then goes actually some of the quickest wins with regards to even understanding what you can start moving forward around.
Yeah, I know the concept also to use generic data and to combine real data with simulated data. Is it also a thing you apply for your yeah things?
Yeah, absolutely, especially with regards to discrete event simulation. So if we know which sort of locos or bogies are in the sort of maintenance depot for a period of time, it's a case of going, well, that part we know is live data or kind of the best understanding of what's there.
Yeah.
But the synthetic data or the emulated data can be, well, for this type of loco, we would expect maintenance to take 6 hours or 8 hours. We can just guess at that point until we start actually understanding and linking into the different systems of tonight, we've only got 5 hours or it's 9 hours, and start to look at those different things. But you build up the confidence, you build up the trust as you start to use the systems as and when more data is available.
So good that I raised that question by myself. So we want some time to collect some more questions from the chat. How do we qualify the performance of a digital twin?
Yeah, you often go back to the same metrics that you're looking at previously. So cost, time, the amount of issues or issue logs of different things, and you still use the traditional business benefits for return on investment.
Yeah. then can features such as instantly taking length measurements, etc., be added to the system? Collecting data from the fields is also very important, for sure.
Absolutely. And this isn't to say digital twins are all around IoT and automatic collection. Digital twins are still very much a end user being on a tablet, inputting a length or inputting a particular thing. If you still have manual pressure gauges or understanding of assets within that sort of process industry, it's still however you get the data into the system can be incorporated into these sort of predictive mechanisms as we move forward.
Yeah, for sure. You have to work also with the interconnection between the rail and the infrastructure, the vehicle and the infrastructure, which is for sure a very important issue for the railway system. Yeah. Mhm.
Absolutely.
Yeah. So, if there are some other questions coming from the chat, or if you have not the opportunity so far to use the chat, please raise your hand for if you have a spontaneous question. For sure, you could also could continue to raise your questions into the chat, and I'm sure that Jonathan will be able to answer you directly in the chat because he is still available. Yeah, if there are no questions for the moment, I would hand over to my colleague Euky from ARUS, the Anatolian Railway Rail Transportation Systems Cluster. Yes, I have to read it. And Euky, to introduce the second speaker.
Thank you, Luz. Good morning. It's a pleasure to be here. I'm Öykü from Anatolia Rail Transportation Systems Cluster, shortly ARUS from Turkey. ARUS, founded in 2012, is a member of ERCI since 2018, and as one of the leading organizations from all over the country, bringing together SMEs, public institutions, and large companies, as well as universities and research centers. Today we are hosting Mr. Zekeriya Polat from one of our members, VisionIT, to make his presentation titled Beyond Simulation, Advancing with Digital Twins. Zekeriya Polat is the innovative founder of VisionIT, which harnesses AI and IoT to revolutionize railway system management, emphasizing sustainability and the principles of the circular economy. With 15 years of experience in the global rail industry, he is dedicated to enhancing asset life cycles and operational efficiency through advanced analytics. Now, Zekeriya, the floor is yours.
You have to unmute. Yes.
Now I guess it's okay.
It works. Yeah.
Thank you, Eke, for a very good introduction. I like the part when you mentioned revolutionizing. I wish I have been doing that, but we've been working on it. So good morning, everyone. Thank you for joining today's session. I represent VisionIT. Today, I'm excited to share our journey with you, a journey that began in 2019 when we embarked on integrating and evolving digital twin technology with railway assets. We are a startup. We started in Ukraine, Kiev. And now our assets that we have been utilizing digital twins deployed across countries, Egypt, Bolivia, Turkey, Ukraine, Poland, and Korea. I titled today's talk Beyond Simulation because despite the popularity of digital twins, as Jonathan mentioned, their depth, the utility are often not fully understood or realized. So in this presentation, I will cover our initial motivations for adopting digital twins, the challenges we faced, and invaluable lessons we have learned along the way, and our failures. Of course, that's the most important part because most of the times people pass that part because it is the part you will understand what you will be working and having efficiency. So I will delve into how we transform digital twins into proactive and intelligent components of our operations working in tandem with our asset management system and engineering teams. Finally, I will discuss these technological investments, how have played an important role in promoting sustainable practices and advancing in circular economy, particularly through extending life cycle of our existing assets. So let's dive in. What are some of the challenges we face when managing our operations? I'm sure we all have similar answers. The obvious one is communication with our trains. Trains are our most valuable assets, yet once they are out on the tracks, it is often feel like they are off the grid. We might find ourselves relying solely on driver feedback, or worse, customer complaints to gauge how things are going. Imagine this. Once train leaves the station, we receive little to no updates on crucial systems. How is the air conditioning holding up? Are the doors functioning correctly? Sometimes we don't hear back even from the drivers themselves. And let's not forget, some of our trains do not return for scheduled maintenance for months. I know some of you might be thinking, well, we don't even get any data from our trains. Well, many companies actually receive data. They are not even aware of it. Sometimes through different systems like trains, operation, and maintenance, it's often overwhelming because most of the companies use many different systems. And some companies that we have seen even use 5, some even use 10. Without a systematic way to collect and integrate this data, we end up flood of numbers and statistics. So what happens then? We are buried under the data, yet without any organized, actionable information. Actually, we have none at all. It is kind of mission impossible trying to make sense of an avalanche of details with no clear starting point. When I mention managing all assets, what exactly do I mean? Well, let me ask you a question. How do I connect train with engineers? Or how can I connect supply chain with trains? Often we find ourselves juggling multiple systems to manage different assets without any connection. But here is the catch. Despite all these systems, they are still essentially operating blind. Why? Because unless these systems are interconnected, all that data isn't just giving us full picture. It is like trying to see with the lights turned off. So without connecting all these assets, we simply can't see the whole story. So when we embarked on this journey, as I said, in 2019, we were certain that a digital twin will be our magic touch. We dreamed of creating a software that will gather all the train data and display it seamlessly to our operations and maintenance teams, as in this video. And we would see failures pop up on the screens, quickly solve problems. We expected clear, useful data, like enjoying perfect blue sky. But reality hit us like a pie in the face, like in the movies. Instead of blue skies, we faced a stormy weather forecast. The trains we were dealing with sent back between 6,000 to 12,000 data per second. I want to repeat this part again. 6,000 to 12,000 data per second from the trains. Trying to monitor all that data in real time through a digital twin felt like we needed an army of people watching it nonstop. Let's not even start on the reliability of data from the technology that's old enough to tell a story, because I told you that some of the assets are more than 10 years, some of them are more than 30 years. Here is the kicker. We eventually learned that even the data from some big name manufacturers had about as much reliability as a weather forecast, like promising a slight chance of rain when it is already raining a lot. So we quickly discovered after this magnificent failure, relying solely on digital twin was like trying to solve a jigsaw puzzle with only half the pieces. keeping our team glued to their screens around the clock? No, that was no go. It was impossible. We needed a smarter solution, something that kept the magic alive without turning into a never-ending screen watching marathon. So we shifted gears to a more proactive and intelligent model, one that could seamlessly integrate and make informed decisions. Instead of diving into artificial intelligence, we opted for more ground approach. We leveraged simple yet effective way to start. Like Jonathan mentioned, starting small. So we developed our first mobile application for asset management system in 2021. We used algorithms derived from our real-world experience to piece together data and the system-based automated work orders, utilized condition monitoring with more reliable data, and created our smart CCTV system to monitor infrastructure for seeing the outside impact. So once we connect all, it sounds easy, but not, we reach our intelligent digital twins. Last 2 years, we have been working on this, and I am excited to show what we achieved. And let's just stay with me. I will try to explain you more with videos and pictures with digital twin itself for you to better understand. So how do we gather, develop, and synthesize all this data? We opted to split our focus into two main categories, digital train and digital depot. As each has its unique dynamics, let's first dive into the first category, into digital train. To make our digital twin truly effective, strong main monitoring, condition monitoring is crucial. We start first by collecting the data and mirroring into the cloud. This data is then integrated into our virtual model, enabling us to conduct real-time monitoring remotely via our mobile and web-based platforms. So we simply actually connect our hardware into the train's car computer, and then use a SIM card to transmit the data. So then you'll be able to see such example that I'm trying to show you here. It is hard to believe, but most of the trains that we have seen until now have got a core computer and data capabilities. For example, we recently worked on 1972 diesel locomotive in Bolivia. Yes, 1972. It is more than older than me. Surprisingly, it had a car computer filled with data that even operating company wasn't aware of it. Primarily because they lack this system display data locomotives. I'm sure most of the people are here, aware of the trains, and when most of the trains have train monitoring systems or human machine interfaces. But in this train, it was lacking, so that they weren't aware that there's a data that they can see. Here is a snapshot that I was trying to explain you. This is latest projects in Seoul, Korea. And this train is driverless and relying entirely on signalization. We kicked off this project 2 months ago. We have equipped it with advanced health status and index page in the digital twin to ensure detailed condition monitoring. This is like on the bottom, you're seeing the train's digital twin itself. The data is about the temperature and the other things that we have been talking about. So our systems monitors each train continuously around the clock, 7 days a week. In the video you are seeing now, we are showcasing one of our projects in Ukraine involving high-speed trains. So in this particular project, we monitor 12 trains. Each train transmits data at a rate of 6,000 per second, including updates on the data includes about the train status, location, failure information, and the information that we also created, like alarms, notifications, map-based visualizations, make it straightforward to monitor, assess the health of each train. So the digital twin that we have been talking about. So In this screenshot from our mobile app, you can see the digital twins of the train. The display gives a detailed overview of various parameters such as doors, pantograph, toilet, restroom, electric components, mileage, both inside and outside temperature. In this video, for example, we are seeing that, if you notice the adjustment, the train makes as it approaches the station, changes its speed, doors opening and closing, and the pantograph lowering. This is the web version of the digital twin systems that you have seen in the mobile. It is showing the same data on the same train. Both the mobile and the web options, we offer the same functionalities. The only difference is the screen size. Whether you are on your mobile or you're at your desk, you have complete access to all the features, and you can monitor. And showing here, as I try to show you maybe a little, if some people connected with their mobile, so that they can see clearly how digital twin is seen on our desktop version. So this is one of the train in Ukraine project. It approaches the station, and once it approaches, it opens the door. You might realize maybe the doors from gray to turn into blue, and then the pantograph is going to be lowered now. Yes, pantograph is lowered, and the speed is zero. You can see that some part here like red, orange, yellow, and some other notifications. I will explain them detail later. So notifications from the system. We provide detailed notifications about each train status, as I told. This includes information on failures, general train conditions, pinpointing exactly what happened, when, where, as well as the frequency of each failure or incident. Based on our extensive experience, we have also implemented additional alarms, such as smoke alarms and emergency brake alerts, passenger area temperature reductions, etc. For example, we have encountered situations where drivers are smoking, sleeping, or eating in the cabins. And in one of our funny experiences that when the drivers were smoking, because they have the screen, they get only the smoke alarm by themselves. And when they get the smoke alarm, they just press the button because they are smoking. They're just ignoring this smoke so that no one is aware of it. But with our systems that integrated, we have this experience, and then the engineers called the driver and saying that we received a smoke alarm. But they were saying that there's no smoke because they were just trying to cover their smoking in the cabin. Additionally, we have an alarm for the emergency brake. This is actually one of the very important things that we have seen with high-speed trains that they are operating also of the cities. If a train applies and its emergency brake remains stationary, let's say for more than 5 minutes, in a location where there is no station, an alarm is triggered. So this alarm sent directly to the engineering team and operation team. Or I'll give you another example. This is very deep engineering that I can explain to you, is that when train hits an obstacle, we realized actually when train hits an obstacle, some of the bogies have different behavior in speed reduction. So if we create this alarm in the system that, for example, if the speed reduces from 100 to 99, 98, 97, rather than 100 to 75 directly, then the system creates automatic work order and the alarm to the engineering team. And we did not use AI on this. It's just a simple experience. And I will try to explain this more in the next coming parts. So you have received the data and you have all the information. What is next, right? And what I'm going to do. The proactive action part is what happens next when we receive a notification or alarm. If the relevant personnel up as an engineer, for example, is close, our system doesn't stop there because we created SMS or Telegram messages. Telegram is kind of WhatsApp application. It is a messaging app to ensure the alert is received by the engineer. This process is closely tied up to what I discussed in the previous slide. It is all driven by the train data and the custom algorithms that we have developed. So we continuously record all the data for what purpose, right? So we all this data allowing us to discern patterns, locations, and the frequency of failures for comparison, Additionally, our unit monitoring system, as you see in this video, lets us dive deeper into the train data over time. It is like a similar, like you having a recorded video. We can fast forward or rewind through the time to observe any failures, see how related systems react when failure detection happens. This capability provides us with profound insights, enabling deeper engineering analysis of any failures and or incident happens. So one of the important things is that automated work orders. This system automatically generates work orders that I've been explaining, serving as the cornerstone of actually condition-based maintenance system. I'm sure most of you heard about the CBM. So I will also try to explain how the CBM is developed on our side. This capability transforms our digital twin from a passive observer into an active participant in our operations. It is a crucial development because it brings intelligence to the forefront, fundamentally changing how we manage maintenance. So our algorithms use straightforward logical rules to assess various scenarios, including the type and the quantity of failures and the specific conditions under which these failures occur. Let me illustrate with a simple example. Consider the doors in the train. Some projects have hundreds of doors. And if there is any problem on the door, for example, or if you need to check the doors in periodical maintenance, it takes hours and hours to check and understand whether they are operating correctly. In this project, for example, that I've been showing in a couple of projects, for example, in Egypt and Ukraine, we have seen that if any doors opens more than it is from standard operation, let's say 6 seconds, its normal standard operation is 5 seconds, then automated work order is generated and then send it to an engineer. The engineer then delegates the repair task to a technician. In urgent situations, I'm sure that some of you ask these questions in your mind, then if there is posing an operational or safety risk, the system takes swift action. By the system, I mean that people together with the system itself, with an engineer, by removing the affected train from the service, or if this happened, I mean this alarm or information that we received in remote areas, let's say 500 kilometers away from the city, on top of a mountain, somewhere that is very far away, then this issue is critical. Then the driver is called, quickly contacted, and to implement preliminary safety measures until the service ends. And we had many experience and examples with this kind of issues. In this example, like I would like to show you a little bit, in detail. You can see this automated work order when it comes. You can see the date. This is, for example, from yesterday. It shows event happened how many times. You see that 51 times between which hours. This is important because sometimes some failure happens like hundreds of times when the train is in an operation. So this is actually one of our latest development. I'm sure most of you have heard about ChatGPT. You heard about Google AI, and most of you are curious, how can we implement this in railway? So this is our Vispo chatbot that we use. How we are using is that we upload all our operational training menus, part catalogs, even technical drawings, all stored securely in our cloud. Whenever an engineer encounters a query or question during the work, they don't need to flip through bulky menus because you have the menus like thousands of pages and you need to know how to look, where to look, right? Instead, they can simply chat with Vispo, like while they are working. Remember the door example that I was talking about? So this is the questions about the door example. So then engineers can ask the Vispo to double check those details. For example, I'm asking like in this question, that you can see about the safety part. And then when the Vispo responds, it shows the reference, the answer it takes, and shows the menus directly going to the page. It shows the answer, as you've seen. What is more is Vispo is multi-language. We are using the multi-language. For example, this manual is English. We have Polish in Poland or Korean in Korea. So you can ask in Korean. If the manual is in Korean, the answer comes in Korean. as you see in this video that, for example, is asking while you are, let's say you are working, and then you need to know door opening and closing time, right? Because you are testing something or you receive the automated work order that you want to know the answer. When you ask this, let's see the answer together. So it gives the answer that, you know, standard opening and closing time for this system in this train 5 plus 1 minus 1 plus minus 1 second. It shows the references of the documents giving this information. You can press, and then it directly shows where this answer is coming from, because there are different doors, right? Like you have passenger access doors, you have a partition door, you have a trap door, and other doors in the system, so that it shows all related ones. So once we establish robust condition monitoring, the next step is to take proactive action, right? Every action that we take is driven by live notifications, insight from condition monitoring, and our accumulated experience, like all culminating in auto work orders. I was explaining that the auto work orders in previous section about taking an action, right? This approach, what we call is condition-based maintenance, or CBM for short. Let me draw your attention to this graphic here. So traditionally, every piece of equipment on a train has a set of maintenance schedule, like based on mileage or based on time. As we gather more data, we start to see how external factors like infrastructure impact the reliability of lifespan of each part. And this data tells us the true lifespan each component, right? So in this graphic, we're seeing the normal lifetime, early lifetime, and end of the lifetime. So what is the condition effective zones for each and every equipment? And if you think about on the large scale, the train itself, right? For like, let's say 15,000 mileage or 30,000 mileage or even a million kilometer heavy general maintenance. So what is the answer of the question when the end of life starts or when it ends? So from our findings, we can begin to adjust the maintenance schedule for each unit. This not only extends the life of both minor and major equipment, but allows us to tailor maintenance periods based on real conditions, not just set intervals, not fixed intervals. Because usually when you have the train, like 20 years of train, you have, and you still use the same manual. We have seen many companies, they are doing the same. So this is like, if you ask me what is condition-based maintenance, this, as you can see, that scheduled maintenance, you can extend from too early to on time. Because we know from those experiences with the intelligent digital twin and then all those data that we received, we can extend without compromising the safety. I will explain more about this in the next coming part. This part of the development cycle, as I have explained, the condition monitoring, proactive action. Once you do develop these two parts, then you are ready to go in this cycle to rescheduling your preventive maintenance. A crucial aspect of our digital train is monitoring the infrastructure, as I explained, that impacts both train operations and performance. Now, the million-dollar question is, how can we enhance passenger comfort and operational safety while also extending component lifespan through condition-based maintenance, like I asked in the previous slide? The answer isn't complete without including smart CCTV systems in our strategy. We have discovered that achieving truly intelligent digital twins isn't feasible without these advanced monitoring tools. Let me show you what I mean by with a couple of video clips, because I will try to zoom in for you better understandings. In the first video, our visual AI system here, this is the pantograph, identifies that the panto is damaged. See here. So this is actually the door opening the prediction. Damaged pantograph, you continue on your operation and you break it. So what are the other parts of this, the smart monitoring system? What we need for? For example, here you see the drivers. There's a driver cabin. You can see how many persons in the cabin. You can see any intrusion. If there are 3 people, you will see it. If they are playing with their mobile, you can see it. Because as I have told you, like they can smoke, they can eat. We have seen people are sleeping there. Believe me. Some people are leaving the cabin. It is because they are close to their home. And this happened in some countries. And in one accident that we know of, many people died. This is the part you can watch and monitor your infrastructure. And here you see that which way the train is operating is using. And also, funnily, you can also see that the window is broken. I'll go a little quickly because I talked so much. I'm sorry to some other parts, like for passenger counting, and you can also go for passenger safety related matters. And to get your attention to TV monitor and refrigerator rather than the people. As I mentioned earlier when introducing what digital twin is, we decided to, intelligent digital twin is, we decided to focus on 2 main aspects, digital trains and digital depots. We have already dived into how digital trains operate and various categories they encompass. Now let's shift our focus and talk about other crucial part of our system, the digital depot. If you recall, I posed a question earlier, how do we effectively connect engineers with trains? The answer lies in implementing a comprehensive digital personnel management system, because human is the part doing the real work. This system must be seamlessly integrated with our maintenance management and supply chain to allow complete oversight. That we can track every work performance of each personnel member and monitor the number of parts they have installed or removed from the trains, while we can see their working hours, their shifts, exactly. I will try to a little bit, if you're looking at your mobile. So this is our web-based systems. It's about digital management, personal management. So you can see the shifts, you can see the whole organization chart. And you can see that because some companies have different locations. I'll quickly go over to the next page because we have time limitations. Digital warehouse. Think of a train as a complex Lego set built from numerous spare parts. It is crucial for us to monitor how each part performs, and we need to track its health and reliability. So why do I emphasize the importance of connecting all assets, engineering teams, trains, and parts? Because when everything is interconnected, we gain the ability to track the mileage and performance of each part with precision. For instance, we don't need a sensor on every window to track its mileage. We know who installed it, right? From the work orders, it's the maintenance management step, at what mileage, when, where. So then system automatically calculates because of the mileage information that it's received from the train. Then we know the mileage of the window when it is removed. So it's just very simple. When you put things together and connect together, then you save so much information than you're actually looking for. So the smart maintenance is the main element of the digital depots, because our core has been the condition-based maintenance. This approach enhances operational efficiency, safety, and reliability by leveraging advanced technologies to monitor and manage every component and asset. Intelligent, interconnected, and highly efficient system. So maybe saying is easy, but if you connect all those, like the smart maintenance system is the core that you need for intelligent digital twin. And then intelligent digital twin. So digital twin to become intelligent, you need smart maintenance management. So digital twins plays a crucial role in advancing the circular economy, right? By allowing the condition-based maintenance. This system ensures that parts are only replaced or maintenance based on the actual need rather than the fixed schedule. This not only extends the lifespan of components, but also significantly reduces waste and inefficiency. Intelligent monitoring, the integration of intelligent monitoring tools like smart CCTV and advanced diagnostic help in identifying potential issues before they become critical. This proactive approach reduces downtime and resources waste, ensuring that trains operate more efficiently and sustainably. Infrastructure analysis, monitoring the infrastructure that affects the train operation is vital. Understanding how infrastructure impacts the reliability and life cycle of train components helps in making informed maintenance decisions. I want to repeat this again, informed maintenance decisions that contribute sustainability by optimizing resource use and minimizing unnecessary replacements. Because many of our clients that we have seen, many of our places that we have been worked, we're seeing this unnecessary replacement over and over again. Resource optimization, by collecting detailed data on performance and wear of various components, the system can predict their end of life more accurately. Remember that I was talking in condition-based maintenance about the life cycle. This leads to better inventory management and procurement strategies, reducing overstocking and underuse of resources, which are key principles in the circular economy. I will not go more into this, and I will go quickly over it. In summary, by leveraging the digital twins, especially intelligent digital twins, smart monitoring and data-driven maintenance strategies, railway system can significantly advance circular economy practices and enhance sustainability. These innovations ensure that resources are used efficiently, waste is minimized, and the environmental impact of railway operations is reduced. So this is my last slide. So what kind of performance we receive, right? If we do this intelligent digital twin. Here's the result from one of our projects that we have been using intelligent digital twins and digital twins itself for 4 years. For 2 years, we use digital twin, and then we applied the intelligent digital twin with informed decisions that I mentioned earlier. I don't want to bore you with many results, but only one as you see in this table. When you look at the table, you can see that these different types of engineering and inspections are reduced by using this intelligent digital twin systems. In some cases, we saved 50% by changing the interval from 10,000 to 20,000 kilometers. And this is all thanks to condition-based maintenance and all the smart maintenance systems and intelligent digital twins that I've been talking about. So I guess I will need to stop here and not go to further to get the questions. Thank you very much.
Thank you, Zekiya, for your presentation. Now we may get questions from the participants. As I start with the first question, I kindly remind the participants that they can use the chat to ask their questions. And the first question is, what are the primary challenges you encountered when integrating digital twins into existing railway systems, and how have you addressed them?
When we started first in 2019, we didn't know that how to get the data. First, we thought we need to get maybe add up sensors. Then we realized actually all the trains that we are working, they have data. Or the data does not need to be coming from the train. It can come from the people when they are working. So generating data or creating data that helps all together. But once we have this digital twin, and we thought that we have this answer, but we did not. And we've actually failed after the first 2 years. We realized that we need to go something into intelligent that helps us to work on informed decisions. So how we address them? Actually, we failed, we learned, and then we changed. This is how we address them, actually, being honest.
Thank you. The second question is about data security and privacy. Considering the sensitive nature of operational data, what measures does Vision take to ensure the security and privacy of data collected and analyzed by digital twins?
I think we need to separate this into two. First, the trains, because in my presentation, I explained that we integrate our hardware into the train and then collect the data and send it to cloud. So there are two parts. First, the train security, data security, and then the cloud security. So in the train security, we use one-way communication. So when we installed our hardware to car computer, we use, again, I'm telling this, is that we use one-way. We get only data from the train, and then we send it to our cloud. Because if you use two-way communications, then if someone infiltrates it, then you will be in trouble. I mean, the train will be in trouble, and the system as a whole will be in trouble. And on the cloud data security, well, we take many approach on this, and I can tell you that it's not easy because we had many attacks. For example, during Ukraine war, especially our system, we got like a millions attack a day. And it wasn't easy, but there are ways to deal with it, but I don't want to go into too much detail. As I said, for data security and privacy, first is the train safety and security, second is the cloud safety and security.
Thank you. Type of mobile phone and capacity.
Type of mobile phone, we first started with Android phones because they are cheaper, and most of the people use Android, especially in the countries that we operate. The capacity, actually, we have an application. If you go into Android or iOS, or if you write VisionIT train tracker, you will be able to see our application. It is easy to download. It just takes 15 seconds. And then you just have your ID and password, then you can log in the system and start using it. I don't know what they mean by capacity, but this is how the system works. I see that the next question about the pantograph, right? You hear me, right? Because I don't hear you. Okay. Yeah,
Yes, now I hear you.
Good.
Yes,
Yeah.
there's a problem with the connection, sorry. Yes,
No problem.
the other question is, what data do you collect of the status of pantographs?
Actually, there are different, so the example that I shared with you, it was the simple camera that we used on pantograph. So the camera data that we collect real time, and we can monitor real time. I cannot show you now, but I can open our system. It's very easy. Then I can show you in real time, but because of data privacy that I cannot show it to you, as I explained. If anyone is interested, we can have maybe private meetings and explain them how it works. But in pantograph, as I said, that we use simple camera. We have our own software that using an AI to detect the problem together on the pantograph itself, and also the overhead catenary itself. Because sometimes overhead catenary on the left and right side, they have some limitations. I don't remember in different countries it's different, but they have some limitations that you can see the camera can collect that data. This is the first, we use visual AI. And the second information we receive from the train, because most of the trains have their pantograph information. It's up or down, or it's like the voltage that it receives, and some other data that I don't recall now, or automatic drop down, for example.
Thank you. Any other questions?
Not from the chat, but we have still some questions on the second slide here. Maybe you can go quickly through these questions, and in the end, there is no question but a remark that I also copied from the chat.
Yes.
I think you can simply answer these questions only reading the report.
Yeah. So this metrics and outcomes that demonstrate the impact measurement. So, for example, I show you in the last part of my slide that how we measure the impact in very easy way, that, you know, how we changed the preventive maintenance work. That is an easy answer. Or if you, I don't even get into the detail that, you know, how our people work in the work environment. They use mobile phones. Before they were gathering together, meetings and all together. For example, before Corona, we had this issue, and we can measure this, as I said, from reliability analysis, because we have the reliability mileage of each and every equipment. There's so many metrics actually we can go in. Future developments. What are the next steps? Actually, we see different, you know, needs and different expectations from different companies, especially with the asset management itself, because the railway is itself still old school. Many companies that we met in the US, in Europe, or in Asia, they don't want to change themselves. They just want to go in the asset management. Digital twin is too far away for them. And they say, why we need this, at what cost, and how long it will take. You know, these many questions that we receive. And we collaborate in innovation, especially, for example, we have partners that we work together. We have a partnering with Intel, for example, with the hardware, and some other the US companies that we are partnering with, and some Swiss companies. And for example, Huawei wanted to partnering with us, especially because of the cameras. And these are the ways that we are collaborating our innovations.
All right. So, Oyku, may I overtake this moderation again? Thank you again for the interesting presentation, Zakaria. And yeah, and for sure, all participants will have the chance to contact you and also Jonathan after the webinar, because we are sending the email addresses and some needed information from this webinar with follow-up email. For sure, we will delay for about 5 minutes because I have still some information to you that might be interesting. At first, we want to know what do you felt about this webinar on organization, on the quality of presentations, and your suggestion for future topics of future ERCI webinars. Oyku is keen to copy and paste the link of these very short feedback questionnaire into the chat. Thank you for that. Then we say something about projects where ERCI as a whole or some clusters of ERCI are involved in. The first one is the success project. It will come to an end. Tomorrow will be the final conference on that. You are free to register for that still. And the project was to support the European SMEs in successfully applying to public procurements in USA, Canada, and Norway. One of the instruments of the projects is the Tenders Watch newsletters, which are issued weekly for USA, for Norway, and for Canada. And you are free to subscribe for these newsletters free of charge by contacting Irina Zarazi or Amelie, or all of them. So the final conference of that project will take place tomorrow. Great opportunity for railway industries and cluster managers to have a summary of lessons learned during the project and to learn about the challenges and opportunities concerning participation in public tenders in these 3 countries. And there will take part special experts from EU institutions, USA, Canada, and Norway, and the railway industry, which are participating in a lively roundtable. That's the right pronunciation of it. So then there are some other opportunities to get in touch with each other. This is a B2B meeting platform coming from the already went STARS project. It was in matching companies with solution providers that support that companies in adopting advanced technologies to improve products, services, manufacturing processes, and organization. If you go to this platform, you are able to build a small profile of you and your company, and to get in touch with other participants of that platform. Then, yeah, the recording of this webinar and also recordings of all other webinars in the past, not of all, but of most of all of them, are visible on the YouTube channel of the STARS project. And yeah, within a few days, maybe not in the afternoon, but we are hurrying to realize this. Then I want to talk about an ongoing project called LEADER 2030. It is learnings for European autonomy to deliver Europe's rail in 2030. It is on closing gaps or closing disruptions of supply chain for raw materials for the railway sector. And the project is called LEADER 2030. And yeah, the synonym is, if you see a pencil, of what material the pencil consists and where the material for this simple pencil come from very different countries. And now you can imagine the complexity of the railway system is quite more complex. And the keywords of this call are supply chain needs for future, supply constraints, risk of supply availabilities to deliver EU rail innovations, and strategic options to ensure resilient solutions and autonomy within Europe. So if you can see, there are different constraints the rail sector is facing in. It is facing with the climate change in the world. It is facing with the availability of raw materials in different countries. It is on yeah, decrease the dependency on single sources, maybe also to ensure more, or to develop more circular economy when reusing of some material. That could be one mitigation measures. And therefore, this project made first a study of the past to identify alerts for the future, and now they are in the status of analyzing the demand side and analyzing the supply side. And the next steps of the project would be forecast of the actual availabilities, gaps, and bottlenecks, and to deliver the final analysis report and recommendations for Europe. The consortium is a very small one. It's led by the European Railway Clusters Initiative, which, as already mentioned, has 17 single regional railway clusters, which are contributing more or less also in this project. We have two technology centers, three technology centers. Is Millennium, the French Rail Research and Innovation Technology Center. We have the Technopark Istanbul, and we have from Germany the Geo Competence Center in Freiberg in Saxony. And about this project, there are some upcoming opportunities for new EU project in the framework of the Horizon Europe. For instance, in the Cluster 5, which is dealing with energy, climate, and transport. There are three suggestions where also rail-related topics could be integrated in such a consortium. If you have any idea, or you have already an initiative to create a consortium, please get in touch with ERCI, with your local cluster, or with us as a whole, and say, oh yeah, we are interested. And if you see the application data, the deadline date for all these 3 calls is the 5th of September 2024. We have therefore about 3.5 months time, but 3.5 months are running, and tomorrow is the 5th of September. Yeah, so you have to think about if this could be interesting to you. Then we picked up also another program called Digital Europe. There are several calls for proposals. We are indicated in the tenders. Funding and tenders portal of the European Commission. For instance, this Digital 2024 Cloud AI 06 MOB space on Common European Mobility Data Space. But they are closing in 2 weeks. That means there is only a small chance to be integrated in such a program. But if you are interested to contribute in Horizon Europe, and maybe you are also a good coordinator to lead a consortium, please get in contact with us, and we are trying to find some further proper consortium partners that you might need for completing your consortium. So we have another B2B matchmaking opportunity organized by the Eskişehir Chamber of Industry together with the Enterprise Europe Network, and 3 meter clusters coming from the automotive, from the railway, and from the aerospace sector. It's a Speed Match 2024 International Networking event. It's a virtual event, online, takes place on the 28th and 29th of May. And for sure, ERCI will be so kind to put also this link for this matchmaking platform into the chat. Same principle as with the STARS matchmaking platform. Install the profile and get in contact with other participants of that platform. So, yeah, there is an identified an open challenge from DB Mindbox. DB Mindbox is the accelerator, especially for startups and small, medium-sized enterprises of Deutsche Bahn, based in Berlin. And they are dealing with the future of railway construction industry, or the road construction industry 2024. And the keywords for this open challenge is work simplification in the construction industry, from planning to construction site, green construction site and planning processes, employee attractiveness, culture, retention and knowledge, and innovative technologies for the construction industry and planning. Yeah, this is the open call, and they are calling all innovators that want to contribute to a more sustainable, modern, technologically advanced railway construction industry with Deutsche Bahn Group and strong industry partners from so-called Future Initiative Railway Construction, in German Zukunftsinitiative Bahnbau. More details also on the keywords you can find by following this link, and the deadline for application, and there's also an online application form and a guideline how to applicate, and a weekly Q&A webinar that takes place on Thursdays, if I'm right, to raise questions. The deadline is the 14th of July 2024. So, and the application process is completely in English, so it is no difficulty for you to apply if you have some solutions that might be interesting from Deutsche Bahn. The winning companies are receiving 25,000 euros and a 3-month mentorship to further develop the idea. So the next ERCI webinar is on the table in 4 weeks. It's on multimodal logistics in Europe. The registration link is still available. You can already register to this webinar free of charge as usual, and will take place on the 12th of June, same time. And we have a list of topics already for further ERCI webinars. For instance, railway international tenders, collaboration channels, monitoring and inspection of rail infrastructure is also a part of the topic we learned today from the application of digital twins, and then human factors in AI and cybersecurity. So, second call to contribute to our feedback questionnaire, and maybe you are interested to present yourself, your innovative solution yourself in one of our next ERCI webinars. When it is the case, please let us know. Now we are 7 minutes late, and sorry for that, but thank you very much for your attendance. Thank you very much to the speakers for their interesting presentations. Thank you for ERCI for excellent co-moderation, and see you soon on the channel. Have a nice day. Bye-bye.